Welcome to PacificAd, and thank you for downloading and viewing our training videos. My name is Jason Britton. I work here at PacificAd, and I'm one of the manufacturing application specialists here. Today's topic is simple FEA analysis, and we're going to cover this first by creating a sketch, which is shown on the next slide here. So we're going to take this sketch, and we're going to extrude it to create a 3D parametric part. And with that part, we're going to go ahead and do FEA analysis on it to get our stresses and safety factors and stuff like that. So to start, let's start by creating a new part within Inventor. And let's go ahead and just recreate that sketch which you saw on the first slide. So as you saw, there were some circles. And also, there were some circles on the right-hand side. So we'll just sketch those real quick. Now we'll go ahead and connect some lines in between the two to go ahead and create the outside of the body. And we'll roughly try to draw them tangent. And let's go ahead and place some dimensions on this to go ahead and give it our design criteria. So I'm going to make this one 2 inches. And I'm going to make the inside hole half of that. So I'm going to take that and divide it by 2. And let's go ahead and make a dimension to center of this. Create that at 3 inches. And from there, let's go ahead and dimension the outside circle to be 1 inch. And again, drive that to be divided by 2 to be half of the outside dimension. And we can now see that we actually didn't get the tangent constraints on there when we drew that. So let's go ahead and place those real quick. Place some tangent constraints on all 4 endpoints of these lines. As you can see, it's changing to be that. Once we have that, we notice the end's still free to rotate. You can see how we got black and blue lines here. So let's go ahead and constrain it a little further by placing a horizontal constraint. So we'll say center to center of these circles is to be horizontal. And then we'll notice in the right hand corner that we are indeed fully constrained. So we know we have a good sketch. We'll go ahead and return so we can go ahead and extrude this and create our part. So we'll bring up the extrude dialog and we'll go ahead and pick these 3 closed profiles here and create our part. So we have 1, 2, and 3, and we'll go ahead and specify a distance of 1/4 inch. Now with that, we can rotate this and see that we do indeed have a 3D parametric part. Now we'll go ahead and go up to our applications and bring up the stress analysis area. Here we can go ahead and choose our material. And we'll go ahead and say that this is made out of mild steel. So we'll go down here and find that real quick. Steel mild, that'll work. And we need to constrain this in some fashion. So if we hold, say, this area, and call that a fixed constraint, that'll take away all 6 degrees of freedom of this part related to that hole. So I'll go ahead and place that as fixed, and I'll go ahead and place a force in the other hole here going in a direction. Let's specify a vector component. So if we look down here, we see the XYZ coordinate system. So we'll say that we have a force in the X direction to say that we're pulling this apart with a 1,000-pound force. With that, now we can go ahead and run the setup here. So we'll go ahead and run the calculation, which is going to create the mesh and calculate the mesh from it. And we'll get our equivalent stresses, our maximum minimal principles, our deformation, and our safety factor. So as that's calculating, we'll see it pop up here. We have our equivalent stress equal to 9,000 psi roughly. Our deformation equal to 3/10,000ths of an inch, and a safety factor equal to 3.3098. Now we see that we might want the safety factor to be a little lower. Perhaps we could save material that way. So perhaps by changing the hole diameter on the right hand side where we're applying the force, we can get rid of some material. So let's go ahead and edit that sketch. And we'll change that hole size. Right now I have it driven to be 1/2 inch. So let's change that and make it to 3/4 of an inch. So we'll go ahead and just type 0.75. Once we have that, it's updated the sketch. Now it's updated the part. Now we'll go to the equivalent stress. Let's run the calculation again. It's going to recalculate all of those things, and we'll get the updated results. Notice we're to 20,000 psi now, and if we go to our safety factor, we're down to 1.44 with a deformation of 7/10,000ths of an inch. So now what I want to do is, well, there's the actual representation of what's going on. And let's go ahead and run a report real quick. So it's going through all that analysis and reporting what is going on there. So we'll get a report here as an HTML. And with that, we can see a few things. Let's go ahead and make this bigger so we can see it better. We can see that I made it, Jason Britton, on Monday, today. Also, we've got the part statistics. So we have the part mass, volume, the nodes and elements which were created in the mesh. We have the material data that I used a mild steel with its modulus and Poisson's ratio and blah blah blah. We also have how I constrained this. I placed 1,000 pounds and fixed the other end. My results are my equivalent stress, all those things we saw on the right. Safety factor 1.44, you notice. Also, we got the figures that came along with those as well, all the results, all the little picture results that we can get. So basically it took a print screen and did the print screen for all those pages and gave us the results of everything. So it saved us quite a bit of work of doing that ourselves. Now we might want to animate the results. So taking that, we can take a look at the deformation, for instance. Animate those results. We'll see the colors change respectively. Now it's not actually deforming because we have actual representation and it's only moving 7/10,000ths of an inch, which we can't see. So if we make that larger, notice that's too large. Let's make a 1:1 so you can see how it's bent or changed the material shape. And we can watch that really quickly. So I hope this helps you, and if you're interested in more training or in this product, please call us here at 1-800-722-2621. My name's Jason Britton. John Ulrich does my position as well, and our sales manager is Steve Rico. Thank you for your time, and hope to hear from you sometime soon. Bye.